Hello dear learners, you're welcome to this tutorial. In this tutorial we are looking at some theorems of circle, that is circle theorem. So by the end of today's tutorial you should be able to define a chord, work on a theorem that says the perpendicular line from the center to a chord divide a chord. Also a theorem on angle subtends by an arc of a circle, and be able to solve problems using these theorems. My name is Ademola Folarin, your mathematics teacher here. This tutorial is powered by IOTA Virtual Learning. So let's start learning. When we say what is a chord is a line segment joining any 2 points of a circumference. A chord is a line segment that is joining any 2 points on a circumference. You know, this is the circumference of a circle. So any straight line such as this is called a chord. A chord is a line that joins any 2 points on a circumference. This is a chord. However, if we have a line from the center of a circle to any point on the circumference, remember, that is a radius. So let's understand, this is radius, this is a chord. There is also a special type of chord that passes through the center of a circle. A special type of chord that passes through the center of a circle that divides a circle into 2 equal parts, that is what we call a diameter. So we know this. 2 times of radius will give us diameter. Diameter is a chord that cuts a circle into 2 equal parts. So a chord is a line segment that joins any 2 points on the circumference of a circle. So understanding this, we can then move into some basic theorems of a circle. Take a look at this theorem. This theorem tells us that 2 equal chords of a circle subtends equal angles at the center. 2 equal chords of a circle subtends equal angles at the center. What does this mean? If these 2 chords AB and PQ are equal, the angle that this makes with the center, that is the angle this chord AB makes with the center of a circle, is equal to the angle this chord PQ makes with the center of the circle. So this angle, let's look at this. What is this saying? If we have this angle, call this alpha, and if this angle is, let's call this beta, that means they are equal. That is, if chord AB is equal to PQ, they are equal, then angle P, if the center of the circle is denoted with O, that will be angle POQ will be equals to angle AOB. So the theorem says 2 equal chords of a circle subtends equal angles at the center of the circle. Yes. Let's take another theorem. Another theorem is saying the perpendicular to a chord bisects the chord if drawn from the center. The perpendicular to a chord bisects the chord if drawn from a center. Take a look at this chord, the chord AB. If we have a perpendicular that is drawn from the center, let's say if this perpendicular meet at the point N, then this means that A AN is equal to NB, because this perpendicular bisects the chord AB. Remember the word bisect. In geometry, it means to cut into two equal parts or to divide into two equal parts. So this established that the perpendicular to a chord bisect chord if drawn from the center of a circle. So any straight line from the center of a circle on a chord bisect the chord into two equal parts. Hence, we can say AB equals AN plus NB. Since AN is equals to NB, we can then say AB will be equals to 2AN, which is the same as saying 2NB. Isn't that interesting? Yes, it is. So don't forget that. Let's go further. This is another theorem that says the angle which an arc subtends at the center, is twice the angle it subtends at any point on the circumference. Let's first carve out from this point B to this point C is what we call an arc. That is an arc. The region of the circumference bounded by two radii. That is an arc. So the angle which this arc subtends at the center of the circle, let's denote that with 0. This is an angle that this arc BC subtends. It is twice the angle it subtends at this point. Basically, what are we saying? This one is saying angle BOC is equals to 2 times of angle BAC. Let's quickly establish that. To do that, I will want us to draw a line from this. Let's draw a line that bisects this, and you see the simple proof of it. Now, drawing this line that bisects this, you will agree with me that this is a radius, this is also a radius, this is also a radius. So this triangle AOB, you will agree with me that the angle here will be the same thing as the angle here. That is the base of an isosceles triangle. So if this angle here is, let's say this is A, and this is also A, the base of an isosceles triangle, right? So how then can we get this part, which is the external? Remember that we can say the sum of opposite interior angles is equal to the exterior angle of a triangle. The sum of opposite interior angle is equal to the exterior. So A plus A will give us 2A here. You remember that rule? So you agree with me by saying this also works for this. Let's say this angle is angle P, and this is also angle P. So being base of an isosceles triangle, they will be equal, and the sum of this opposite interior angle will be equal to the exterior angle of the triangle. That's 2P. So now we agree that BAC, angle BAC equals A plus P. Let's take note of that. Now that we have established this, you will also see that angle BOC is equals to 2A plus 2p. Factorizing this, we have 2a plus p, right? So remember that this is a plus p. Then we can conclude that BOC equals 2 open bracket BAC. So you see that the angle subtends by this arc BC, which is this, is 2 times the angle subtends by the same arc at this point. So we say the angle subtends at the center by a arc or by an arc at that point is twice the angle subtends by the same arc at any point on the circumference. Very good. That's an interesting theorem under circle geometry that we must take seriously. Moving further, with that little knowledge, we can look at these problems. We are to find the value of y in each case. We should find the value of y in each case. Look at this case number 1. We want to find the value of y. Remember that we have already learned that the angle subtends by an arc at the center is twice the angle subtends by the same arc at the circumference, which is basically POR. Angle POR is 2 times of PQR. Now that we know that POR is 2y equals 2 multiplied by 86 degrees. So in doing that, we will say 2y equals, we are going to multiply this 86 by 2. So whatever it gives us, that will be 172 degrees. Then we can divide both sides by by 2. That will be y is equals to 172 divided by 2 equals, what would that give us? That will be 86 degrees. So our y still remain 86 degrees. Interesting. Let's look at the second problem. The second problem here is that we are interested in finding the value of y using the same knowledge that we have earlier acquired. If we label this part to be A, B, and this is C, and the midpoint here is O, you realize that we can use the theorem angle subtends by arc at the center is twice the angle subtends by the same arc at the circumference, which means AOB is equals to 2 times of ACB. So when we are saying AOB, the AOB is the angle we have here. That will be the angle we have here and not this. Recall, our interest is to find y. So going further, now that we know this, AOB will be 2 times of this. That will be 2 multiplied by 64 degrees. And when we do that, that will be 128 degrees. Now that we know AOB to be 128 degrees, by AOB we mean this angle. If you look at this, angle at a point is 360. That means angle AOB subtracted from 360 will give us y. Therefore, we can say y is equals to 360 degrees minus AOB. That's because as angle at a point, is 360. So then our y will be equals to 360 degrees minus 128 degrees. So our y will be equals to, when you subtract 128 from 360, what do we have? So that will be 232 degrees. So we can say angle y is equals to 232 degrees. You see the logic? We have to, since we know this angle, we have to get this angle. After getting this angle, we subtract it from 360, which is angle at a point, to get this angle y. Interesting, right? Good. So let's go further. Let's solve one more problem. In a situation like this, we are asked to find the value of x in this problem. In this diagram, we are asked to find the value of x. To be able to get the value of x here, let's not forget that we can say ABOC is a quadrilateral. ABOC. You see that line? AB, BO, OC, back to CA is a quadrilateral. So we know that sum of angles in a quadrilateral is equal to 360 degrees. Sum of angles in a quadrilateral equals 360 degrees. Now that we know that, you agree with me that for us to solve this problem, we have to get this angle. In order to get this angle, let's label this angle small a. So let's get that angle small a, which is easy for us to get. To get that angle small a, it means we are going to get this angle here, so that we know this. And to get this angle, that is, we need angle. Recall that since angle subtends by an arc at the center is twice the one subtends by the arc at the circumference. So you agree to say BOC is equals to 2 times of BAC, which means BOC is 2A. That is the A here. To get BOC, we have to subtract 220 degrees from 360. That will be 360 degrees minus 220 degrees equals 2A. This is because of angle at a point. So if we do that, we are left with 140, that is 140 degrees equals 2A. Then we divide both sides by 2. So our answer here will be 70 degrees equals A. Now that we know A to be 70 degrees, we can then go back to the point where we say the sum of angles in a quadrilateral equals to 360 degrees. So 360 degrees equals the sum of the angles in a quadrilateral, which is going to be 42 degrees plus A plus 220 degrees plus X. Since our interest is to determine the value of X, we then say we had this 42 degrees plus A is 70 degrees plus 220 degrees plus X equals 360 degrees. Now that we know this, what is left for us is to add all these angles which is 42 plus 70 degrees plus 220 degrees. What will this give us? 332 degrees plus x equals 360 degrees. So from here we can say x will be equals to 360 degrees minus 332 degrees, which that will give us 28 degrees. X equals 28 degrees. So you can see how we've been able to use the knowledge of the theorem that says angle subtended by an arc to the center of a circle is twice the angle subtended by the same arc to any point on the circumference. Yes, that is very interesting. So we've been able to learn something important about two basic rules. The rule says whenever we have a circle, in a simple way, whenever we have a circle and the center of a circle is this, so if this is arc AB, the angle this arc make with the center of the circle, it is twice the angle that this same arc makes with any point on the circumference, whether it is like this or it is this. So whatever that angle, this angle here now, if this is x, this will also be x, because they are formed from the same arc. Is that taken? That is as a result of the angle made by the center, by the arc to the center. So if this is x, this place will be 2x. That is telling us that the angle subtended by the arc to the center of a circle is twice the angle subtended by the same arc at any point on the circumference. Again, we also learned that for a circle with two chords equal, if we have a circle in which two chords are equal to each other, the angle the two chords makes with the center, that is, if we have it this way, the angle here will be the same thing as the angle this will make with the center. That is, if this is x, this will also be x, since these two chords are equal. So we've learned that, and we shall learn more in our subsequent tutorials. But let's try problems around these two theorems that we've learned. If you enjoyed this tutorial, don't forget to click on the like button and as well subscribe to our channel for more interesting and educative videos like this. Till I come your way next time, my name is Folani Ademola, and I'm telling you that mathematics is fun.